Okay, so we can start with the other session, the short talk session, and I'm pleased to invite here Ioanna Grypari, presenting a work entitled The PathOS Project, Evidence, Methods, Tools, and Lessons Learned for Identifying the Impact of Open Science.
Hi, everyone. You can hear me well? Yes? And I can change this? Okay, good. Are you going to throw something at me when it's 10 minutes? Okay, good. So thanks for having me here in this ridiculously beautiful room. So I'm Ioanna Grypari, and I'm the coordinator of PathOS project. I am at Athena Research Center and OpenAIRE. So we got together to figure out if our open science plans are working. So, the main objective of PathOS was to identify and quantify the key impact pathways across different parts of a society and help understand what's really going on so that policy making can be more targeted and efficient. We started by gathering the state of the art and then going above that in various ways. One of them was to focus on causality, so trying to really attribute impacts to open science and not other things that are happening at the same time. We operationalized specific open science indicators, some new ones, some existed already, and tried to understand what works and what doesn't. We used new AI-assisted methodologies wherever it fit, and other methods that I will talk about later. And also we formulated a cost-benefit analysis framework that puts a euro value on actual open science practices and can help decision-making. So the project, unfortunately, it's almost over, but I just want to put this here because it's a great group of organizations and it's been going very well. So I'm going to talk about three different things: the evidence that we have gathered and how we contribute to it, the methods, and the tools. In terms of evidence, we started by conducting a huge scoping review, and we found 725 scientific papers on open science impact. That's a good base, yes? No. Unfortunately, there is still a lot of work to be done, but it's a good place to start. So in terms of academic impact, the instruments that have been mostly studied are open access, citizen science, and open and fair data. And the impact dimensions that have been looked at are citations, so effect of different instruments on citations, quality, efficiency, and productivity, and so on. Now here the results vary a lot depending both on the impact dimension that one examines and the open science instrument. For example, for citations, there is a small to moderate increase from open access, citizen science, and open and fair data, but no effect from other things that have been studied, such as open code, at least in the specific publications. For efficiency and productivity, the results are positive, so that there is an effect from most of these instruments. So I am not here to say like what works and what doesn't, but there is a publication out with this, so someone can take a closer look and see. The context really matters. In terms of societal impact, citizen science has been mostly studied. This is not so surprising. So when you want to see the effect of science on the society, the closest link between them is looking at the citizens when they are involved in science directly. So the effects, the types of impact that have been looked at is education and awareness, climate and environment, engagement, and so on. The mechanisms that work here are mostly participatory. So you participate in research or in the creation of data, or you use it, and then you end up having an impact. So as you see, I am sure you're already thinking of several things that are missing from here. So in terms of economic impact, it's much more difficult. There are only 27 publications, and there is not so much focus on causality there or on identifying anything beyond the medical and biotech sector. Of course, this makes sense. Company data is scarce, and it tends to be private. And then when we look at economic impact, we look at one step further. So you have an open access instrument like publications and open and fair data. It's used in academia, and then a company takes it and does something else with it. So once you move one step away, it's more difficult to track. And the further away you move, the more difficult it is to track. So there are several issues and a lot of things that we can do to work better. One of them is to have more clear definitions for open science impact and try to throw light in areas that have not been studied. There are publications out for all these things, so you can take a look. Now, we try to enhance the evidence by focusing on 6 different case studies. So for bioinformatics, we examined if Elixir's open sources, how they affect industry. So in fact, they lead to cost saving, they affect skill production, and there's a lot of collaboration between academia and industry because of them. In COVID, the COVID-19 case study, we looked if the R in FAIR has an effect. So if datasets and software that are reusable and not just open have an effect in uptake in clinical trials, clinical guidelines, and patents, and they do. In climate and AI, we looked at how open access publications affect the persistence of topics. So if academia is still working more and more on the same issues, and uptake by industry, and women as first authors, and they found a positive effect there. For the data repositories case study, we found that in social sciences, the type of repository really matters in terms of reuse and citations, something to think about when designing a repository. In the France case study, we looked at Open Edition HAL and Research Data Gouv, and we saw that they have a lot of uptake and use by non-academics, so industry and society. And we're studying now what types of publications have this attention, so what are the fields that are really contributing here. And then we looked at the National Open Access Repository of Portugal, ARCAP, and we found that it's being used by a lot of companies, leading them to some cost savings as well. Now, I see a lot of faces going, oh, and then a lot of faces going, no way they found this. So let's go to methods. So how could we attribute these things? We have self-selection, reverse causality, hidden variables, many things changing at the same time. So what do you do to approach this? Of course, this is not a statistical or econometrics project, but we did everything together. So we used mixed methods, so quantitative and qualitative data, AI-supported analytics that I will talk about in a second, well-established causality methods, and to triangulated evidence whenever possible. So I invite you, when these case studies are out, to take a look and judge them also and give us some feedback. So why did I mention AI-driven analytics? So one thing that we found across the project was that in the methods that are being used so far, the big data that we have available now and the AI-driven stuff, it's not being used enough given the stuff that it offers, and also open data sets as well. So in a particular case study, we use the OpenAIRE graph that has 196 million publications, and PatStat that has about 200 million records of patents. So what does this allow us to do? So when you think about when you think about causality, immediately you're like, oh, I have to control for this. Well, if you have big data, you can control for all these things. You know, you can find a treatment group and a control group. Of course, then afterwards you have to see, oh, are these groups that I control so many things for representative of the population? And then talking about longevity of impact and how to track things after project, well, when you can extract using AI from the publication the particular innovation, not just the citation of it, you can see how it goes later on, what's the pathway that it follows in the economy, in the society, and so on. And that's a huge tool. Okay, talking about tools, the indicator handbook is one of the things we created, led by CWTS. There are some indicators that are well developed, like Citations, for example, and Open Science instruments, and some others that need a lot of work. So it's important here, first of all, this works like wiki, so you can go and add comments and change, and we'll approve it if it makes sense. And so please take a look and use it, and this is going to stay after the project ends. So a lot of work to be done here, especially to add methods for economic and societal impact. I'm not going to go through this, I'm just briefly going to say that a lot of the tools that we use, so the ones at the top are all using AI, will be added to the handbook, and I think it's important for everyone that is working on similar type of stuff or their own methodologies to add them as well. It's okay to say that it's been tested only here, for example, right? Because the handbook works as a recipe book. It has all the ingredients and limitations and stuff. It's written on the indicators. The last thing I want to say before Silvio kills me is that about the cost-benefit analysis framework, of course we cannot present everything now, but at the session later, Alessandra from CSIL is going to present how we proxy the benefit part. So one important thing here is that you end up having to put values, euro values, to intangibles. So one would say, do we even want to do this? Do I want a dollar measure of having something with a lot of citations? And the answer is that maybe no, but maybe it will be convincing to policymakers, funders, and so on to tell them, you know, you're going to save so much money from this. And lastly, I'm going to use this opportunity to invite you to our event at in the summer with UNESCO, OSMI, OSC Track, and OpenAIRE. The in-person attendance is full, unfortunately, but you can join online, and would love to have such a nice group give their opinions on stuff. Thank you.
Okay. Any question from the audience? Coffee will arrive in a couple of minutes, but first. Anyone?
It's good, they liked it. I wasn't confusing at all.
Okay, I do have one. Actually, you have analyzed a lot of different dimensions to measure somehow impacts from different perspectives and so on. We know the traditional one, we have discussed about it a lot, citations, for instance, and these kind of things. According to your specific research there, which kind of surprises you have got actually?
Which kind of?
Surprises you have got in that analysis. So the usual one, okay, citations, yes, fine. We expected that. There is something that was unexpected that emerged from your analysis.
Well, there is a couple of things. Two that come to mind is that when we found that there are more women as first authors in open access publications in climate and AI, which by the way is a male-dominated field, we controlled for the balance in the number of authors between male and female. So it was very surprising to see a strong effect once you controlled for the team. And another thing we found from Elixir in the case study that they did is that training costs are way, way higher than anyone ever estimates. So there's a lot of, I mean, I don't know, maybe it makes sense to a lot of people, but it was the highest cost for them to train people for that. Okay.
Okay, some other questions from the audience? Doubts, curiosity to ask? None? Okay.
Thank you.
Ioanna, thank you again.
So much.
So let me invite here Nees for the next talk entitled Accuracy of Affiliation Information in Open Bibliographic Data Sources, a comparative study of OpenAlex and OpenAIRE for Leiden University. Thank you, Nees.
Yeah, thanks a lot for the nice introduction. So in my talk I will focus on the accuracy of affiliation data in open bibliographic data sources. And, well, I think we all know that accurate affiliation information is essential for all kinds of bibliometric analysis and also institutional reporting. And therefore, this type of data really plays also a critical role in all kinds of discussions about the transition towards making use of open bibliographic data sources. So really the topic that we have discussed yesterday that we are also focusing on today. And when I talk with research managers, policymakers about this transition towards making use of open bibliographic data sources, often the accuracy of affiliation information pops up. It is seen as one of the barriers not yet to transition away from proprietary data sources. And at the same time, relatively little is known about the completeness and accuracy of this type of information in open bibliographic data sources. So therefore the aim of our study was really to study this, so to study the accuracy of affiliation information in two prominent open bibliographic data sources, OpenAlex and OpenAIRE. And to keep things simple and manageable, we have limited ourselves to only those research outputs that are attributed to Leiden University. So what we did is the following. We selected all 2020-2023 publications indexed in both OpenAlex and OpenAIRE with the DOI. And then in a second step, we identified the selected publications attributed to Leiden University in either of those data sources. And finally, we matched the publications from both sources based on DOI. And then we performed manual validations of random samples of publications. So we really inspected the landing pages and the PDFs of those publications to see whether there is a Leiden University affiliation included in those publications. And here are the results. So we found 42,000 publications attributed to Leiden University in both of those data sources. And we identified three groups of publications. And I will discuss those three groups right now. So first of all, the publications in the overlap. So about 30,000 publications. And since those publications are attributed to Leiden University in both OpenAlex and OpenAIRE, it is, I think, reasonable to assume that those publications really contain a Leiden University affiliation. And a manual validation of 30 random publications confirmed this. So in all 30 publications, we indeed found a Leiden University affiliation string. Let's then look at the publications attributed to Leiden University exclusively in OpenAlex. So 4,500 publications. So those publications are also included in OpenAIRE, but in OpenAIRE they are not attributed to Leiden University. Again, we performed a manual validation of 30 publications, and in all 30 publications we found a Leiden University affiliation string. So this means that they are correctly attributed to Leiden University in OpenAlex, but well, they are missing an attribution in OpenAIRE. So they are false negatives in OpenAIRE. And then finally, the publications attributed to Leiden University exclusively in OpenAIRE, about 7,300 publications. And over here, our manual validation of 30 publications showed a mixed situation. So in 19 publications we found a Leiden University affiliation string. So these are correctly attributed to Leiden University in OpenAIRE, and they are missing an attribution in OpenAlex, so false negatives in OpenAlex. And in 11 publications we did not find a Leiden University affiliation. So false positives in OpenAIRE and true negatives in OpenAlex. Based on those figures, we can calculate precision recall numbers. The numbers are not visible on the slide, unfortunately. There is a technical problem, but well, I know them by heart. So the recall for those data sources is exactly the same in our analysis. So we can calculate estimates based on our findings for Leiden University, for the Leiden University publications. The recall for both data sources is 88%. Based on our findings, and in the case of OpenAlex we found a precision of 100%, and in the case of OpenAIRE the precision is somewhat lower, 93%. And this was mainly due to the false positives. Well, it's nice that we have those numbers now available for Leiden University, but it does not say much about the performance of other universities, of course. Now, for me, those numbers are not really the most important thing that we can learn from this study. So for me, what was also really valuable are the insights that we gained while performing this study. So what we really learned is the power of open data. So the fact that OpenAlex, OpenAIRE, that they are open, that also made it possible that we are in the first place are able to perform such an in-depth study. So the missing or incorrect attributions can be identified because the data is open. And therefore analysis like ours are possible. And analysis like ours can then also be used to identify potential issues. And when we are able to identify potential issues, make them visible, share them with the data sources, then we are also able to implement improvements. Then we can improve. So that's also what we did. So we shared our findings with the teams of OpenAlex, OpenAIRE, and I was very happy to first of all see that they are very responsive. So they are really eager to make those improvements. And OpenAIRE has already started to make concrete steps and implement improvements based on our findings. And this also brings me to well, a recommendation for open data sources. So please include raw affiliation strings and other types of information based on which attributions are made, and include this in your data that you expose to users. Because this helps users to understand whether incorrect attributions are caused by inaccurate or missing data, or by mistakes made by the linking approach that is used. Then we can ask ourselves the question how to improve affiliation information further in those open bibliographic data sources. Well, there are different directions. One direction is to focus on improving the models that are used by those data sources to link raw affiliation strings to organizations. And there are already several studies in the literature available in which a comparison is made between the models used by OpenAlex, OpenAIRE, Semantic Scholar. New models are also proposed, but in my opinion, all those studies, they have a particular weakness. They are all based on relatively small data sets. So small data sets are used for training and evaluating those models. And, well, we all know affiliation data is highly complex. And a data set of 1,000, 2,000, 3,000 cases is not really representative of this highly complex type of data. So if you think about situations in France, you cannot cover that in a data set of 1,000 cases. So what would be then a good next step? And this brings me back to the power of open data, to see whether we can utilize again this power. So I believe it is worthwhile to see whether we can invest in all kinds of tools, approaches that facilitate manual validation and correction of attributions. So tools that can be used by the community to do curation work. And there are already initiatives in this space. A tool that is worthwhile to mention is Work Magnets. It is a tool developed by the French Ministry of Higher Education and Research, and the tool can be used to check all the mappings of the raw affiliation strings to raw identifiers in OpenAlex. So the tool can be used to check all those mappings, to see them, to add missing mappings, and to correct wrong mappings. OpenAIRE has something similar. They have a tool called OpenAlex. This tool is only accessible by curators of OpenAIRE, but the idea is the same. So existing mappings can be checked, missing mappings can be added, and wrong mappings can be corrected. But this also brings some questions. How can we avoid duplicate work by the community? And how can we make curation work reusable? So if we do curation work for one data source, how can we make sure that we can also reuse that work for another data source? Or reuse that work to test some existing models or train new models? And this brings me to a second set of recommendations, this time for data sources and the community. So align different curation initiatives and make the results of community curation openly available and interoperable. And with this in mind, I would like to also recommend you to look at COMET. COMET was introduced yesterday by John. It stands for Collaborative Metadata Enrichment Task Force, and the aim of this task force is to build a community approach to metadata enrichment. And if we, the community, together with the data sources, can make this to a success, then I think we can go to a situation where we can go back to the policymakers, the research managers, and say, well, I think it's now time to move to the open bibliographic data sources. And with this, I would like to thank you.
Any question from the audience?
Yeah, thanks for making the case for collaborative curation. I deeply care about that. One question I have to you and also to the Barcelona team, essentially, is whether we should get the signatories of Barcelona to release open affiliation data. Because one problem we run into if we want to do this kind of thing across institutions is affiliation data is not public. So we as someone who is not in the institution don't normally know when somebody started or ended being affiliated. And that really makes it very hard to do anything useful at scale beyond a single institution.
Yeah, one possibility is of course to also point to ORCID. I think ORCID can really play an important role over here. ORCID is established to, partly to solve this question, of course. So in ORCID you can register your affiliations and also the exact time period in which you as a researcher was affiliated to a particular organization. But then, of course, yeah, the question is again, how can we make sure that researchers really adopt these types of tools? And over there is a big role for us, the community. How can we organize this collectively? So raising awareness of these types of issues is really of importance, and demonstrate what is currently lacking that prevents us to really make this step towards open bibliographic data sources. And in that way, I think, we can really make a hard case. Yeah.
Thank you, Nees. Great presentation. Very well done. My first question is about, perhaps, mostly about recall. So your study focuses on the data subset in the two sources that identify links with Leiden University, but and which is fine because it can give insight about the agreement and disagreement of the two sources, but it doesn't. In the case that both OpenAlex and OpenAIRE fail to identify a link to Leiden University, this wouldn't surface. So we don't know the truth, let's say. Yeah. So it doesn't add up in the tally of the recall. So I was wondering whether you have, because you are familiar with your own institution, I was wondering whether you have access to a complete list of the publication that should have been identified by both, so that you could perhaps provide a better estimation of the recall, first question. And second question is about the sample. So you're adopting these 30 sample for every group. And I was wondering whether repeating the comparison with a different sample could yield different results, like fluctuations in the metrics, as in like confidence interval to be adequate statistically.
Yeah. Thanks for those questions. Yeah, so you are completely right. So we have limited ourselves to only those publications with an attribution to Leiden University in either OpenAlex or OpenAIRE. So most likely there are also publications in both databases that are on both sides missing a link to Leiden University. We can investigate that. So in Leiden University we have also an institutional repository. So we can do some checks over there. But my impression is that, well, this will be really a minor part of the whole picture. So I believe the estimates that we can derive from this analysis are quite okay. At least they are giving us a high-level picture based on which we have really have been able to identify the main issues that are occurring in those sources. And it also brings me to your second question. We in fact have repeated this exercise twice because, well, you know this, we have been done it on your request, based on the request of OpenAIRE. So OpenAIRE, so when we started with analysis, we have used a data dump of OpenAIRE of the graph from 2024, and well, earlier this year, January 2025, there was a new release in OpenAIRE, so we repeated the analysis based on the latest data, and that was really also very insightful because of that repetition. We also learned that the main findings, the main issues are really similar. So we have seen some improvements in the case of OpenAIRE. We have also seen some slight difference on the side of OpenAlex, but really the main issues, the main biases in the data were similar. So I think although the samples are relatively small, they are really powerful to uncover some main issues. And yeah, that is also very valuable to share with all of you. By doing these small exercises, you can really make some progress.
Okay, I know that there are other questions, but I will suggest you to catch up with Nees during the break, and we have to move on. Thank you, Nees. And so next talk is by Tomasz Umerle, and that it is entitled OpenCitations for SSH, Improving Operance Metrics and Enriching Knowledge Graphs. Yes, Tomasz Umerle and Angelo Di Iorio. Apologies for that, I miss it.
Hello, good morning everyone. So I'm going to speak today about the collaboration between Opera's infrastructure and OpenCitations team in two projects. So just a couple of words to begin with about Operas. Operas is a consortium. It's currently AISBL, but on the road NNS3. but on the road to become ERIC in around 3 years. And it's for open scholarly communication, social sciences, and humanities. So one of our main services and also our contribution to open infrastructure landscape, we're also supporters of Barcelona Declaration, is GoTriple, which is a discovery platform from SSH content, currently more than 19 million records, with like more careful coverage of smaller languages. So it's a multilingual platform. And we've kind of closed the first phase of development in 2023. It was a Horizon project, and then we sought funding, and now we are in this huge research and development phase with 2 projects, Lumen and Graphia. And yes, so in both projects, we are targeting our main services, but a little bit a different way. So in Graphia project, the focus is on implementing graph technologies for SSH scholarly communication, creation of SSH knowledge graph, but also enhancing GoTriple to be a graph technology-based infrastructure. And in Lumen, we will deliver GoTriple software as a white solution, white label software solution through EOSC. So with other disciplines like molecular dynamics, mathematics, or sciences, but for both projects, we are in dire need of good quality citation data. That's why OPERAS works with OpenCitations in both projects to do that. So, and why is that so? So we are one of the key silent contributors of academia's missing references, like SSH community, because we are not, like historically, traditionally, our publications are not that standardized. It's not about DOI to DOI kind of relationships of publications. So we are in need of extracting information from papers, from footnotes, so to be able to have a better quality metadata, to be able to do responsible research evaluation based on our infrastructure, which is specifically for SSH, to enhance discovery and to accelerate knowledge discovery and support researchers in SSH. So now to Angelo, who will talk a little bit about how we will approach it in both projects.
Okay, can I? Okay, hello everybody. I'm Angelo from the University of Bologna, Department of Computer Science. Not nice like this, but we are the same university. So here we just describe a little bit a project we are working on together with OPERAS and also with other people here in the room. Before starting, I would also like to thank Marta that I saw at the bottom, at the end of the room, because she's the actual developer of what I'm talking about. So she's doing the real job while I'm here just to describe the overall picture. So the point here is the extraction of citation in the social science and humanities. So most of the people here are familiar with the problems. We have different standards, different formats for writing the bibliographic references. Some of them are standardized, some others are not. And we have some peculiar problems in this context instead of others. So for instance, if you think about footnotes, we have an example here of some references that are in footnotes. So in some cases, the footnote itself contains the full reference. So all the data that we would like to extract are there. But in other cases, for instance, there are links between different footnotes. So in this example, you have, I don't know if you can read it, but there is a footnote that contains a reference to the previous one. So there is the OP-CIT syntax, which is this abbreviation that helps us to connect something that has already been cited in the previous footnote. So all these kind of problems need to be tackled in order to extract the bibliographic references in this kind of context. And we need some approaches that are specific for this case, and this is what we would like to work on within the Graphia project. So our role within the Graphia project is to work on this kind of aspects, but we would like to start from some tools that we have already developed in other projects. So this is also a connection with other people here in the room, because we built this new tool on top of another one, which is called Check Citation Extractor and Classifier. This is basically a tool that takes as input some PDF files and tries to extract the citations from these files. The tool has been developed within the GraspOS project that will be described, by the way, in the next talk. So Tomasz will describe more details about the project. The project is about a responsible research assessment. So in order to do this kind of assessment, you definitely need to extract the citations. So just to give you an overview, the tool is actually built by two main components that communicate each other. The first one is responsible of extracting the citations, and is actually composed by two sub-modules. In the first one, the tool takes as input PDF files, and using a Grobid external tool, basically extracts all the citation. Actually, we are not using Grobid as is, but we retrained the Grobid models with some extended datasets. The second step in this first part is the translation of the output of the first step, which is in XML format, TEI, in some JSON that contains all the sentences and all the data that can be exported to other services as well. So I haven't put the numbers here, but the performance of the tool is quite aligned with Grobid. So the F1 score, for instance, is about 0.82, which is not that high yet, but we are still working on to refine some aspects of the tool. The second part is about the classification of citation intents. So the goal here is to try to understand why the paper is being cited. We are doing some experiments with some large language models, and the performance here are quite good as well. So they are slightly above the state of the art. What is most interesting here is the left part of the diagram, because this is something on which we would like to work for the Graphia project. In particular, we want to explore a new direction, which is using large language models to perform the first part of the task. I'm also very happy that there will be a talk about this exact topic today in the morning time, so I'm eager to listen to the talk, because I think there are very good connections. We just started in that direction. We just performed very simple experiments, so the results are not ready yet on that part. The other part, one point which I think is interesting here is also to use LLM to disambiguate the references, to try to understand which are the papers that is being cited. So in our preliminary experiments, that part seemed to be possible to be solved by using LLM. So I think something good results can be achieved there. The last part is about the contribution to the Graphia knowledge graph. You know that Graphia is aiming at creating this SSH knowledge graph. So what we want to do is to export all this kind of data in a format that is compliant to the knowledge graph. We are actually using the OCDM, so Open Citation Data Model, and the idea is to integrate this output in the Graphia knowledge graph. We do not want to duplicate data, but just to create connection with these two parts. So this is the first part, this is the second one. Just to recap what we are doing now, our goal is to produce this, first of all, citation index for the social science and humanities, so that can be integrated with the Graphia knowledge graph, but also to explore this new direction. So using LLM for the task that we have been performing by using Grobid so far. So I would like to stress on one point, which is the current status. What we are doing right now is to work on a data set that has been used first of all to train Grobid, but we would like to use the same data set for the LLM experiments as well. So the data set is currently composed of 112 articles that were collectively manually annotated, starting from an existing data set in the past. There are about 4,000 citations, and this can be exported in different formats, so XML, JSON, JSON-LD. I would like to stress on this point to connect to the previous talk, because the previous speaker was talking about community-based effort to annotate data, and so we think this is another, this is a very important point as well. So far, this is an experiment that we're carrying out internally in our team. We would like to extend the experiment with other people in the project, but having the help of the whole community would be helpful here as well. So I think I truly support this idea of the comet that was described in the previous talk as a way to work all together also in this kind of context. So I think I was on time. Thank you, everybody.
Okay. Oh, yes, Daniel.
Yeah, I'm a bit surprised that your gold standard is so small. Have you looked at Wikisource, for instance? There you have thousands of examples where a PDF document has been transcribed, the references have been annotated as such, and they cover all sorts of topics and disciplines and things like that.
Yeah, one point is about in the gold standard here, we are also including so thanks for the suggestion, first of all, but in the gold standard, we are also including the full text of the papers. So it's not just the citation that has been extracted, but also the annotation of the in-text reference pointers. So in that case, there is the same kind of level of granularity. Okay, we'll check it, thanks.
Other questions?
Thank you for your talk. You mentioned the fact that you're using the first part of GrowBit only, and not the fact that then it can extract references. But would you like to compare what goes out of your chain and what goes out of a full GrowBit at one point?
Yes.
Okay.
Yes, when I say the first part I was mentioning, because we started with the GrowBit dataset and we measured both the segmentation part, which is responsible for extracting the structure, and the references. So
okay.
I do not have the data here, but we did some comparison on a small data set so far. So we want to extend it, but compare all the different steps.
Thank you.
Last quick question.
If not, I have an advertisement.
Please go ahead.
So, if you would like to know more about Go Triple Data, so we have an open call for anyone interested in playing with Go Triple Data set. We offer free support of a data scientist in another project, doesn't matter which one, but you know, you can access it. The deadline is pretty close, but we'll probably extend it a bit. So any topics around data services that we are developing, we are supporting you and expecting you to test some of the features that we are developing. So, and it's easy form to submit, please consider it.
Okay, thank you guys. So last short talk before coffee, that is from Thanasis Vergoulis. Entitled GraspOS Infrastructure, Enhancing Discoverability of Open Resources for Responsible Research Assessment. Thanasis.
Okay, hi everyone. I know I'm the last thing standing between you and the coffee break, so we'll try to be in time. How can I change the... okay, it works. So my name is Thanasis Vergoulis, and I am the Chief Technical Manager of the GraspOS project, mentioned also by Angelo in the previous talk. And I prepared this particular submission together with Clifford Tatum from CWTS, also a partner of this project. So I will just present today one of the key exploitable results of the project, the GraspOS infrastructure. So I will mention very quickly the general mission of the project, but I will not say a lot about that. If you are interested, you can find me and talk during the coffee break. So the problem that we are trying to address is related to the fact that the research assessment field has several problems related to open science activities and openness in general. A first problem is that the effort that researchers and research organizations are giving towards open science is not always properly acknowledged. So there is a need for a research assessment framework that is responsible but also takes into consideration the open science aspect. this thing that we call it the Open Science Aware Responsible Research Assessment concept. And of course, we need also some resources, tools, data, services, but also maybe guidelines to support this kind of research assessment practices. Then, although there are various open resources that can support responsible research assessment, it's not always easy to discover them and to better understand them, to see which resource works better for a particular use case or for another one. And there is a need for a one-stop destination to discover and understand this kind of resources. Finally, we have identified that there is a lack of standardization related to the metadata that are being used by such resources, maybe such datasets and tools and services. They all rely to particular types of metadata, and there is a lack of standardization regarding this in the way that these kind of metadata sources are exposing their contents. So this raises obstacles in creating useful value-added services that can help toward this, addressing these problems. Something important to mention is that our project is an EOSC-related project. So for those that are not familiar with EOSC, it is the European Open Science Cloud, a virtual environment that can help researchers in Europe to share, access, and reuse research data and services. And it has the aim to promote open science principles in general. EOSC offers a lot of services to researchers in Europe and in general. For instance, there is this EOSC Resource Hub service that can help people discover research artifacts like publications, datasets, or research software packages, but also services. And at some point, before the funding of our project, European Commission and EOSC together have acknowledged that there is a need to further support open science aware responsible research assessment practices, and this is when our project came, GraspOS. It is an European Commission funded EOSC related project that aims to develop, assess and put into operation an EOSC integrated open federated infrastructure to support the open science aware responsible research assessment practices and to pave the way for the respective reforms. So this is a bird's eye view of the main architecture of the infrastructure. So a lot of details are missing. The first thing to mention is that this infrastructure is trying to cover four types of resources, four main types of resources: data, tools, services, and templates and guidelines. And for each of those resources, it collects rich metadata according to a particular metadata schema that we are developing. It is called GraspOS Resource Metadata Schema and will be published in the coming months. We have a draft version of that until now that we are using for internal purposes. And this metadata schema is designed to capture important dimensions for research assessment cases. Then something other important to mention is that this metadata schema is extending the metadata standards that are used by EOSC so that we can easily integrate the resources that we collect in our infrastructure into the EOSC ecosystem. We also use under the hood some EOSC connected catalogs that are automatically harvested by the EOSC Resource Hub so that every resource that we put into the GraspOS infrastructure can be discoverable inside EOSC. But on the other hand, in our infrastructure, we keep more detailed metadata that can help discoverability, exploration, and better understanding of the resources in the context of research assessment use cases. Finally, the infrastructure offers a front-end UI built on top of those rich metadata that focuses on supporting exploration of the resources in a convenient way, helping different kinds of end users to find the appropriate resources for their use cases. And it aspires to become the de facto point of reference for anyone looking for resources around research assessment. Something that I forgot to mention is that because we have identified this lack in standardization in the metadata for this kind of metadata sources, we have also put a lot of effort in creating the GraspOS API specification, which is a standard that can be used for any such resource to share their data through an API. It is based on the SKGIF metadata model that is being developed by a working group of RDA for scholarly knowledge graphs. But it is based on an extension of that, the first official extension of the SKGIF model. It is called Array SKG, and it is an extension that also covers some additional notions that are not covered by the core SKGIF model, like indicators and narrative CVs and things like that. If you are interested in these extensions and these specifications, I have included the links inside the slides, so those slides will be shared and you can find them. And before closing, I would like to give you some screenshots from this front-end UI. It looks like this right now. It is in beta, in private beta. You can use some exploration paths, for example, browse the resources based on some particular dimensions, like the stages of the scope methodology that are related to, or identify resources based on the subject of assessment that they are focusing on. We have identified some important such exploration paths that we have implemented already, and we are in the process of adding a couple more. And you can combine those exploration paths together with keyword-based search to better refine the exploration of resources. And there are also some additional filters that are tailored to each of the different categories to further refine the results, and sorting functionality as well. Now, in early summer, we plan to release the public beta of the GraspOS infrastructure. So this infrastructure that I show you will be available very soon for everyone, and this will include the first batch of resources, those that are very core to the GraspOS infrastructure, coming from the partners of the project. In autumn, we will have the production-ready public release that will include more resources, again coming from the partners of the project, and by the end of the year, we plan to release a clear resource inclusion policy, having various criteria on how to include your own resource in this particular infrastructure, so that it can be discoverable. And with that, I would like to thank you for your attention.
So, any question from the audience?
When is the coffee break?
Just after your question and answer. Okay? Oh, I do have one actually, because you have presented a lot of different platform with a lot of different services that can be used basically to facilitate, to support research assessment and responsible research assessment in general. And I wanted to know if within the project you are going to also try to use these tools for running experiments in existing assessment exercise with the partners, for instance, or something like that.
This is an excellent question. The project has 9 pilots, so they are in different categories, focusing in different types of use cases of research assessment scenarios. So by principle, the design of the different services that have been extended or developed in the context of the project was done based on requirements provided from those pilots, and some testing has been done. Not every pilot tested or used all of the services that were part of the project, but at least a a part of those tools and services and datasets have been used in practice in some scenarios. And the feedback was provided to the service and tool providers so that they can improve their resources in a way that helps those use cases. And a lot of the guidelines and the templates that are included also inside the infrastructure were based on some consultation with the pilots. So we had various stakeholder groups represented in these pilots, and this was the way that we tried to do this thing in the context of the project.
Questions? Other questions? Okay, so let's thank Thanasis again for the introduction.